I'm just going to do a quick video this evening. This is going to be handheld, most of this, to help Radio Cruncher set up his Wobbulator on an FM radio. I'm going to do this with a radio I haven't got any instructions for, just to try and show you basically what you're looking for and how to do it. It's fairly straightforward once you get your head around what the thing's actually doing. You've got to remember this is a sweep generator, and basically the Wobbulator sweeps around a centre frequency. As you can see on this display at the bottom here, we're centered at 10.7 megahertz and we're sweeping either side of 10.7 megahertz. Now, connection wise, which I know he was interested in, the sweep output, not the RF output, the swept output goes to the X input of the oscilloscope. The RF output goes to the input of the IF amplifier, and I'll show you which connections I'm making on this radio in a moment. The scope ideally should be an analog scope. This is the digital scope. You need to run in XY mode, and I'll show you that in a moment. But most scopes will have an XY mode. It should be fairly straightforward. So the generator's been on for, I don't know, an hour probably now, and it's, as I say, sweeping around 10.7 megahertz. You can check that with the crystal oscillator, assuming that's correct. So what I'm doing is I'm taking, this is the RF lead here, and here's the RF, and I'm basically all I'm doing is injecting that into the oscillator coil. Now, ideally you want to connect it directly to the IF amplifier, but the trouble with connecting anything directly to the IF amplifier, you're going to alter the matching of the IF amplifier. So what I'm doing is I'm putting the signal in before the IF amplifier, so I don't disturb any of the impedance or matching of the IF amplifier, and I'm feeding in a fairly strong signal into the RF section. So that's our RF signals coming in here, okay, and we're putting in the 10.7 swept frequency from the Wobbulator, so that comes into this point here. The ground connection is actually not connected at all, and you can actually just loosely couple this. If you've got an FM radio, you can actually just wrap that around the FM aerial. That works quite well as well. I could have done that. I could have connected it up to the FM aerial. I tend not to try and make physical connections to a radio unless it's absolutely necessary, or the instruction manual says it, and I haven't got the manual for this radio. Now, the output is connected to this jack plug. So basically, we're not interested, and you've got to remember this. This is what kept confusing me. You're not looking at RF. What you're looking at the response of the final detector circuit. This is our final detector stage here. This blue core here is our FM discriminator, and you'll see if you have a look behind here. I'm not going to move it around too much. There's two diodes here. They're your diode detectors here. You're looking at that response, and you're looking for that response on the scope. Now, that scope, what we're looking at is the center frequency. We're looking at the S curve because you're in J mode or XY mode. Scope's in XY mode at the moment. So basically, we're looking at the center point is 0. Anything positive is one way, and anything negative is the other way. So we're either side of the detector. So we're going positive and negative through the detector as the sweep passes through. Now, what I'm going to do is I'm going to run through the procedure. The other thing that's really useful, unless you could be absolutely sure you know where you are, is it's nice to know exactly where your 10.7 megahertz center frequency is, because you want that in the center of the S curve, and I'll try and show that in a moment. What I use, and I bought this on eBay, this little Webster Electronics marker generator. It's a great little thing, very straightforward crystal oscillator, but all I do is I put that near the radio. I'll put that near the radio, and I'll turn this, let me set the scope up so you can see. Unfortunately, it's very tricky because I haven't got any tripods here. Can you see that little glitch on that marker? That's your 10.7 megahertz marker, and that's basically where the sweep's passing through, and it's beating with the 10.7 megahertz from this little marker generator. Okay, so that's what we've basically got, roughly the setup procedure, right? Often takes a bit of adjusting of RF levels. You've got to get the RF level down as low as possible. Obviously, we don't activate the AGC circuit. So let me just try and set this up so you can see what's happening. Right, I'll talk you through roughly what I'm doing. So we want an S curve, and you've seen the sort of in all the textbooks the perfect S curve. You'll never get the perfect S curve. It always seems to be a sort of like a compromise. Because our sweep frequency is only 50 Hertz, what I suggest you do, because there shouldn't be any DC component on the output of the amplifier, make sure your scope's direct coupled. It gives you a slightly better response, because obviously there's a charging time of the capacitors in the decoupling circuit of the scope, and it's a fairly low sweep speed. It gives you a slightly better waveform and gives you a better idea of what's happening. So we've got our marker. We can see our markers. That's our 10.7 megahertz reference. It's useful also because if the Philips Wobbulator drifts slightly, we still know our reference point. So we'll get that centered, and now we're going to basically put the minimum amount of signal in, which I've basically got. I'm just turning the volume up a bit now, and we're going to see if we can improve this signal. With quite a low drive at the moment. Okay, so that's a bit more volume. So I'm going to adjust the first IF transformer. Okay, you see that marker's quite strong. I can move the signal, the marker generator away slightly, so it doesn't interfere so much. Just slightly away. There we go. Reduce the marker slightly. So we're adjusting the first transformer. Now this is basically a bit of twiddling around to get this right. There's the first IF. This is the second IF. And it's, see the right hand side is quite a nice S, but it's not in the centre of the screen. This will be the third IF. Doesn't make an awful lot of difference. And this is your discriminator core, which usually makes the biggest difference. There we go. So that's actually brought that closer. So I'm going to turn the volume down on the radio slightly. I'm going to go back and start again on the first IF. I'm trying to get this back portion up higher. And it was the second IF. See, that's a little bit better. You're not necessarily looking for amplitude, you're looking for symmetry. Let's try again. Okay. See, that's better. You see, we've got symmetry now. Let's bring this up a bit. There we go. There's the S. It's looking a lot better already, actually. Let's go. We try and get a bit of amplitude back. Obviously, we want amplitude because that's our sensitivity, but we also want a nice linear S. Okay, we're really peaking that up a bit now. Let's turn the volume down a bit more. Let's turn the RF gain down from the Wobbulator. It's pretty well peaked, that one. Yep, that's good. Go back to the first IF transform again. Pretty good. Second IF. It's well peaked. And discriminator or final detector. I mean, you could be here all day fiddling and farting around. Basically what you want is the most amplitude, and you want the nicest S curve, and that, I think, even if I do say so myself, is a pretty good S curve. But you see, this is the discriminator that makes has the biggest influence on the center position of that marker. But that's a pretty good S curve. I'm actually using a metal screwdriver here, but it doesn't affect it too much. So that's the sort of response you're looking for. I hope that was of some use. Start again. Hope that was of some use. And if you want any more questions, please ask.